Hi students, welcome back to my channel Evolve Solving Physics. Today we are going to discuss some applications when an object is freely falling. At the same time the object is projected vertically upward. So based on that concept we are going to discuss one application. For suppose one object, that is body 1, releasing from the top of the tower at the same instant means at the same time body 2 is projected vertically up, has shown. Then see the figure here. Let us consider this is the tower, this is the top of the tower. At the top of the tower the body 1 is released from the top of the tower. At the same time the body 2 is projected vertically up and the height of the tower is h. So let us consider the height. We don't know the height of the tower, so we are considering the height of the tower as h. I said that the displacement or distance traveled by the object which is projected vertically upward or freely falling can be considered as height. So height of the tower is h. So now we are going to find some terms based on this concept. We are going to find height at which they meet is. So at what, this is the total height of the tower. What they say to find at what point of height the two objects will meet. The two objects will meet. This is the total height of the tower. What they say to find height at which they meet is at what point of height the two bodies are going to meet. So don't know at what time they will meet, at what heights they are going to meet. So let t be the time at which two bodies will meet. So we don't know the time, at what time that these two bodies will meet at a height. So at a point of meet of two bodies that will be equal to the total distance h. So if an object is, the object or the body 1 is falling freely and at the same time the object 2 is projected vertically upward. For suppose if the two objects meet at this point, this is the distance traveled by the first object, that is s1, and this is the distance traveled by the object in upward direction, that is s2. So these two distances will be equal to the h. So the object which is the body 1 which is freely falling at the distance of s1 and the object which is projected vertically upward with a distance of s2, at these two distances will form a total distance h. We don't know how much distance, at what distance these two objects are going to meet. So I am considering the distance traveled by the first body is s1 and distance traveled by the second body is s2. When we combine these two distances, that will be equal to the total distance. Total distance means height h, tower height. So this is the height traveled by the freely falling body s1 and this is the height travel or distance traveled by the object which is projected upward, that will be equal to the height of the tower. So h equals to s1 plus s2. h is h itself and s1. For s1 means for a body 1 is freely falling. So s1 distance is s1. So you know that s equals to ut plus half at square. For freely falling u equals to 0, a equals to g and s equals to, as I am taking as time as t equals to t. Why I am taking time t here? At the time of meet, at the time t, they two are going to meet, I have considered here. So we are taking time as t itself. Okay, this is the time of meet. And for s2 is body 2 projected vertically upward, that is vertically upward means u equals to u, a equals to minus z, and t equals to t itself. That is s2 equals to ut plus half at square. Substitute these values here. Ut plus half at square for s1 plus ut plus half at square. That is, this is for s1 and this is for s2. So for s1, u equals to 0, u plus half a is g, t is t itself, plus ut is ut itself, u only na. A is minus z, minus half gt square. Minus half gt square plus half gt square will be cancelled. 0 plus anything will be anything, ut. So h equals to ut. So height at which they meet is h equals to ut. That equals to, and at what time they are going to meet is t equals to h by u. At time t with a height of h with initial velocity u, they are going to meet. So this is the time at which they are going to meet, t equals to h by u, and the height at which they are going to meet is h equals to ut. Now what they are saying, an object or a body 1 is releasing from the top of the tower, at the same time the body 2 is vertically projected vertically upward. Based on that concept, what they say to find the time after which their velocities are equal is, what they are saying that the velocities are equal after time t. After time t, I said at the time of meet, the velocities will be equal. We have discussed in previous class that the velocities will be equal after time t. What we are going to find means when the velocities are equal after time t, at what time the velocities are going to be equal. Let the velocities are equal, be equal after a time t. So velocities are equal means, let us consider v1 be the velocity of body 1 is equal to the v2 will be the velocity of body 2 which is projected vertically upward. At the when these two velocities are equal, at this point we are going to find the time t. When the velocities of two bodies are equal, at that point we are going to find the time t. Okay, velocity v1, u1 plus at is equal to u2 plus at. This is freely falling. This is vertically upward. So freely falling is u0 plus gt is equal to u plus minus gt. So gt is equal to u minus gt. Send this here, gt plus gt is equal to u, 2gt is equal to u. We want time. After time t, the velocities are equal. So we are going to find that time when the velocities are equal. T is equal to u by 2g. This is the time after which the velocities are equal. So now we are going to discuss one more important application which is very important in problem solving. So what they have given means a body falls freely from the height h. So a body falls freely from the height h. This is the height traveled by the object. So this is the point at which the body is reaching the ground. We are considering this point as q. So a body is freely falling from the height h. Height h means it is reaching the ground. So the height of the body is, the height traveled by the body is h. Means the distance traveled by the body is height h, which is freely falling towards the ground. So after t seconds of fall, so we don't know the how much time taken by the body to reach the ground. So after t seconds of fall, the gravity ceased to act. Find the time of flight. Time of flight is the total time taken by the body to reach the ground. So let t is the, here they say to find time of flight means total time. Let t be the total time taken. What they said, this is the t is the total time to reach the body to the ground of height h. But what they said, after t seconds of fall. So first suppose this is the t seconds of fall. This is the t seconds of fall. Gravity ceased to act. Gravity ceased to act means at that point the object remains in air, means there is no gravity. Gravity ceases means no gravity is acting on the body after time t seconds of fall. It's the total time taken by the body to reach the ground. After t seconds, the gravity ceases to be act on the body, means at that point there is no gravity acting on the body, means the body is struck at that point, that is p. Here the body, here at the point p, there is no gravity acting on the body. No gravity acting on the body means the body won't falls on the ground. Why? Because without gravity no body falls freely. If we have gravity, I said acceleration due to gravity means due to earth attraction the body which reaches the ground. Here no gravity is acting at after t seconds of time, no gravity is acting on the body, that is gravity is ceasing. So at the point p, okay, find the time of flight. So they say to find the total time t. So we know that time t before ceasing the gravity, the body has an gravity up to t seconds. After t seconds the body is ceased, means no, the body is not falling. They said after obtaining the gravity, they said to find the total time t. So based on this concept, so when gravity is ceased after time t seconds, we are going to find the total time t. So at which point we are considering the gravity ceases? At point p. Let gravity ceases at p after t seconds. So that is at p. At p the body does not acting any gravity, so the body is struck in air. Without gravity the body does not reaches the ground. So at p g is equal to 0. G means acceleration due to gravity will be 0 when the object does not have any gravity. Gravity is ceasing here. So at point p the body has no gravity, so g equals to 0. And what will be the velocity here? The velocity will be constant, same. So there will be, when gravity is 0, there will be no change in the velocity. So v is equal to constant. Just remember that when gravity ceases, the velocity will remains constant. So now what we are going to find? We are going to find the time t, total time t. Before going to calculate time t, we are going to find some terms. To find the total time, we are going to calculate some another points to get the total time of flight, that is total time t. So what they said, that the distance traveled by the body to reach the ground is h. So when the gravity ceases after time t seconds, so after time t seconds the body ceases at point p. At this point the velocity v is constant and z will be 0. So before gravity ceases, it travels a distance of x here. So distance covered in t seconds is, so x. Distance traveled by the body before ceasing is x. Total is h. Before gravity ceases, the distance traveled is considered as x after t seconds. So distance covered in t seconds is s equals to ut plus half at square. T seconds means what we have taken distance as x. Freely falling, u is 0 plus half a is g t square. So x equals to half gt squared. This is the distance travelled by the body in t seconds before gravity ceases. And remaining distance, that is, so this is the, let us consider this as point O. So O to P, the distance is x equals to half gt squared, and the remaining distance is PQ. We don't know that time here, that is considered as t dash. So after t seconds of time, the body ceases its gravity, that is at point P. So from P to Q means after gravity ceasing to reach the ground, the time taken is t dash. T dash. So the distance remaining distance means to reach the ground, the object to reach the ground after ceasing, PQ, is to be converted by the body. So at point P to Q, it travels with a constant velocity. I said at point P, z equals to 0 and v will be constant. So the body from point to Q, from point P to Q, it should travel with a constant velocity, that is v equals to constant. So the remaining distance PQ is converted by body with constant velocity. Then, so we know that velocity is equal to distance by time or displacement by time. So SPQ. So SPQ is the distance traveled from P to Q, and the time is t dash. So distance now SPQ is equal to V into t dash. VP. Why I am taking VP? VP means from point P, the object contains a constant velocity to reach the ground, that is at point Q. At point P, what will be the velocity? That is, the velocity at P is V equals to U plus AT, VP equals to U is 0 plus GT. So VP equals to GT. This is the constant velocity travel by the body at point P, from point P. So from the point P to Q, it travels with a velocity of GT. This is the constant velocity, that is the object is travelled from P to Q. I am considering this as equation 1 and 2. And this is 3. From 2. Now we are going to find the total time taken by the body to reach the ground after gravity ceasing. With gravity ceasing means after ceasing the gravity, the object is moving towards the ground with constant velocity. From 2, what we have from 2, SPQ equals to VP into T dash. So from equation 2, SPQ equals to VP into T dash. So T dash can be written as SPQ by VP. So to get the distance SPQ, what we can write? So here H is the total distance traveled by the body. So this is the x is the distance travel before gravity ceases. At a time t, the distance traveled by the body is x. Distance traveled from P to Q is SPQ. So SPQ can be written as h minus x. Why I wrote this h minus x? Because if you subtract h minus x, you will get SPQ. So from total distance, if you remove the time t distance, you will get the distance of SPQ. H minus x, you will get SPQ. So VP is from equation 3. VP is GT. Consider this as equation 4. So T dash equals to, what is H here? H is H itself, total height traveled by the body, and X is, what we got X here from 1, half GT square. Half GT square from 1. X equals to half GT square. So by GT, split here GT. H by GT minus half GT square by GT. GG will be cancelled and T will be cancelled. H by GT minus T by 2. This is the time T dash. So the distance at time T, the distance travelled by the object is x. At time T dash, the distance travelled will be SPQ. If you add these two times, you will get the total time T. So total time T, capital T equals to T plus T dash. What is the time T? Is T itself plus travel by the object before ceasing. So T equals to T dash is H by GT minus T by 2. This is the total time traveled by the body. So these can be written as T equals to T minus T by 2 can be written as T by GT plus T by 2. This is the total time taken by the body to reach the ground. So T plus T dash. So why I found this x value here? So to know x value, I found the distance traveled from O to P, and to find T dash, I found the distance traveled from P to Q. At point P, the velocity will be constant. With that constant velocity, the body should reach the ground, that is point Q. So based on this concept, you will get a question in your exam, that is in MSET, mainly in MSET. So you can also get an multiple choice question in JEE NEET exams. So just remember that to get total time, so before ceasing time and after ceasing time, if you add both the times, you will get the total time T. If you have any doubts, please comment me in comment box. Please like, share and subscribe my channel. Thank you.